Now let's take a look at trigonometric equations, how to solve those. And our first problem, there it goes. It's like this. Get my pen to work here. There it goes. It's got 1 minus sine theta equals 3/2. And it says solve each equation on the interval 0 to 2 pi. And this is solving a trig equation with a single trig function. And I need to get my unit circle up and running here. There it is. Okay. Well, first thing we need to do is get the trig function by itself. So get trig function by itself. We don't want any numbers in front of it, any numbers after it. So I'm going to take this negative sine theta to the right side, and I'll take 3/2 to the left side. So it becomes 1 minus 3/2 equals sine theta. Take anything over the other side. Anything across the equals sign changes. Now 1 minus 3/2 gives us negative 1/2. And we got sine theta is equal to negative 1/2. And now we're going to look the answers up on the unit circle. Now sine is your y on your unit circle. So we're going to look around our unit circle, and we're going to look where sine, our y part, is equal to negative 1/2. Okay, so looking at our y's, we're going around here, don't see negative 1/2. Get down to here. Here's a, wait a minute, it helps if I look in the right, the y's. It's still a bit too early for me. Here's negative 1/2, so 7 pi over 6. And keep going. Here's another negative 1/2, 11 pi over 6. So those would be my answers. Let's take a look at this one. We've got 4 sine squared theta equals 3. Well, we're going to try to get the trig function by itself. So first thing we do is divide both sides by 4. Like that. And we get sine squared is equal to 3/4. Now this is a square root property, because I could rewrite this in this manner. Sine theta to the second power. And the square root property says if you got something squared, doesn't say what it has to be, but you got something squared equal to something else, then you drop your squared, and you put a plus or minus square root around the other side. Now we can't have a fraction inside of a square root, so we'll split it up, put a square root on top, square root around the bottom. Can't have a square root downstairs, but square root of 4 works out as 2. So that one actually comes out pretty nice. So we got the trig function by itself. So now we're going to go around our unit circle, and we're going to look for where the y part, because sine is our y, is equal to either a positive square root of 3 over 2 or a negative square root of 3 over 2. Okay, so looking at our y part, here's a positive square root of 3 over 2, so pi over 3. Here's a positive square root of 3 over 2, so 2 pi over 3. Look at my y parts. Coming down to here, here's a negative square root of 3 over 2, so 4 pi over 3. And I keep going, and here's another, our last one, 5 pi over 3. So those would be our 4 answers. Let's look at this one. This one's a little bit different. Cosine theta over 2 is equal to 1/2. Now, the trig function's by itself, but instead of having theta here, we'll have theta over 2. Well, how we handle that is we're going to look up on a unit circle where cosine is equal to 1/2. So let's go look at our first place. Cosine is our x part. It's equal to 1/2 right here, pi over 3. And go all the way around over to here. It's also equal to 1/2 over here, 5 pi over 3. Now let's start off with those. We may have to add more on. After you come up with these, you then set this value right here equal to this right here. We're going to set this value right here equal to that value. So we have theta over 2 is equal to pi over 3. And we have theta over 2 is equal to 5 pi over 3. Now we want to solve these. So here I'll multiply both sides by 2. Like that. And these 2's cancel. And then our first answer is going to be 2 pi over 3. Okay. Then we'll do the same thing here. Multiply both sides by 2. And these 2's cancel. 2 times 5 is 10. So we got 10 pi over 3. Which is 3 and 1/3 pi. Like that. The reason why I point that out is this particular problem said we want our answers between 0 and 2 pi. This answer just went past 2 pi. So we don't want this one. This is our only answer. Now, when you have a fraction here, like pi or theta over 2, theta over 3, theta over 5, you're probably just going to have either one answer or 0 answers. If you have a 5 in here, like 5 theta, that's where you'll have maybe 10 answers. And we'll see an example of that. So let's look at our fourth one here. This is minus 1. And we're looking between 0 and 2 pi again. Okay. We want to get the trig function by itself. So I'm going to take negative 1 over to the right side. And then we get square root of 3 tangent theta is equal to 1. Divide both sides by square root of 3. That should be a square root there. And get this. These square root of 3's cancel. Can't have a square root downstairs, so multiply top and bottom by the square root of 3. And we get tangent theta is equal to square root of 3 over 3. Well, if we go to our unit circle, tangent is y over x. So if I look at pi over 6 here, we'd have 1/2 over square root of 3 over 2, 1 over square root of 3, which would be square root of 3 over 3. So pi over 6 is one of our answers. Now here we're saying tangent's positive. There's only two quadrants where tangent's positive, and that's the first quadrant and the third quadrant. So if I come down here, and by symmetry actually, if I follow this pi over 6 over, the straight line over to here, this, if I put y over x, a negative 1/2 over a negative square root of 3 over 2, 2's would cancel, the negatives would cancel, and we'd have 1 over square root of 3, which is square root of 3 over 3. So 7 pi over 6 is our other answer. So we got two answers to that problem. Let me save this. Trigonometric equations, page 01. There we go. And let's look at our next problem. We have cosine 3 theta is equal square root of 2 over 2. And, well, the trig functions by itself, so what we're doing is we're looking up where cosine is equal to the square root of 2 over 2. And I'll do it in a vertical format here. Usually I do it horizontally, go across, but let's try this. Okay. Now, first place, I go look at my unit circle. Cosine is our x part, and we're looking for its square root of 2 over 2. Well, these are the pi over 4 marks, but here's square root of 2 over 2. So we've got pi over 4. And there's one other place. Come down to here. The x is our cosine, so 7 pi over 4. That right there. Okay. Now, since we have more than a single theta here, we're going to set this equal to this and equal to this. So we got 3 theta is equal to pi over 4. Multiply both sides by 1/3. And we're going to get I don't think I like this particular format. I know we just started, but let me erase all that. Okay. I thought it'd look better. I never have put it in vertical format. Let's start over. There we go. Sorry about that. Okay, so we're going to look where cosine of something is equal to square root of 2 over 2. And we said it was pi over 4. And we also said it was down here, 7 pi over 4. Okay, let's start with those. Again, we're setting the 3 theta equal to each one of these. So here we got 3 theta is equal to pi over 4. I multiply both sides by 1/3. Those 3's cancel, and we got theta is equal to pi over 12. So that's our first answer. Now in this one, again, I'm going to set whatever's up here equal to this. So I got 3 theta is equal to 7 pi over 4. Now I'm not going to show the steps, same as these. Multiply both sides by 1/3, and we get theta is equal to 7 pi over 12. So that's directly on our unit circle there. But if I take pi over 4, I'm right here, and I go all the way around, I'm back to where I started. So another answer is going to be this first answer plus 2 pi. So I got pi over 4 plus 2 pi. So cosine of 2 pi times 4 is 8 pi, 9 pi over 4 is also equal to that. If I took my second answer here, 7 pi over 4, and I added 2 pi, I'd be back to where I was. So we got 7 pi over 4 plus 2 pi. 2 pi times 4 is 8 pi, plus 7 pi is 15 pi. And again, we take 3 theta, we set equal to each one of these. So I said 3 theta is equal to 9 pi over 4. Multiply both sides by 1/3, and we get 9 pi over 12, which is 3 pi over 4. That's our third answer. This one, same thing. We're going to set 3 theta equal to this. So I got 3 theta is equal to 15 pi over 4. Multiply both sides by 1/3, and we got 15 pi over 12, which gives us 5 pi over 4. Okay. Now, if we took pi over 4, our first answer, instead of adding 2 pi, we add 4 pi. We're still back to the same location. 4 pi times 4 is 16, plus 1 is 17 pi. So cosine of 17 pi over 4 is also equal to square root of 2 over 2. And if I take my second answer, the 7 pi over 4, and I add 4 pi, I'm back to the same place. 4 times 4 is 16 pi, plus this 23 pi, I believe, over 4. Oops. 23 pi. So we'll have cosine of 23 pi over 4 is also equal to square root of 2 over 2. Well, same idea. We're going to set 3 theta equal to this, and 3 theta equal to this. So we've got 3 theta is equal to 17 pi over 4. Multiply both sides by 1/3, and we get 17 pi over 12. Now here, we got 3 theta is equal to 23 pi over 4. Multiply both sides by 1/3, and we get 23 pi over 12. When do you stop? You know, you can sit there and do this the rest of your life. It says specifically we want our answers to be between 0 and 2 pi. If I did one more, and see the pattern. We took our first answer plus 2 pi, second answer plus 2 pi. First answer plus 4 pi, second answer plus 4 pi. So the next one would be our first answer plus 6 pi. So then we get cosine 6 times 4 is 24, so we've got 24 pi plus 1 is 25 pi over 4 is also equal to square root of 2 over 2. And again, I said 3 theta equal to that. Multiply both sides by 1/3, and we get 25 pi over 12. Problem with this answer is 12 goes in 25 2 times, so we've got 2 and 1/12 pi. This right here has gone beyond 2 pi, which is our stopping place. So we can't use this answer. So when do you stop? Well, you just keep doing it until your answer goes past 2 pi, and then you're done. Now, I made a statement in class. I haven't done enough of these to really say. I'd almost hazard a guess, based upon the examples I've done, that if you got 3 theta here, you'll have 6 answers. If you have 2 theta here you'll have 4 answers. If you have 4 theta, you'll have 8 answers. Don't know if that's always true, but that seems to be the pattern. Pattern doesn't always necessarily mean the truth, though. Well, let's look at another one. We've got sine of theta over 5 minus pi over 2 equals negative square root of 3 over 2. Now, let me grab a drink here. Now the trig functions by itself. So now we just look up on our unit circle. We're looking where sine of something is equal to negative square root of 3 over 2. And there's be 2 places there. So let me go ahead and write the second one down while I'm at it. Okay, so negative square root of 3 over 2. Well, it's down here in quadrant 3 and 4. Negative square root of 3 over 2 is, sine is our y, so it's right here. So 4 pi over 3. And the other place is right here, which is 5 pi over 3. And again, whatever is right here inside your parentheses is what you're going to set equal to each one of these. So we got theta over 5 minus pi over 2 equals 4 pi over 3. If this was a normal equation, we would multiply everything by the LCM of all our denominators to get rid of the fractions. And I'll go ahead and do that just to show it. Let's see, 5, 2, and 3 be 30. So multiply everything by 30. I tend to ignore this in trig usually. But if you struggle with fractions, get rid of them to begin with. That's what I'm showing this step. 5 and 30, this is 1. This is 6. 2 and 30, that's 1. This is 15. 3 and 30, this is 1. And this is 10. So we've got 6 theta minus 15 pi is equal to 40 pi. Well, I'm going to take the negative 15 pi to the right side. It becomes a positive 15 pi. 40 plus 15 gives us 55 pi. And then divide both sides by 6. And we get theta is equal to, how many times did I go into that? 9? 9 and 1/6 pi? Which is definitely past 2 pi, isn't it? So our first answer actually went past 2 pi, which we can't use it then. Because it says your answer should be in the form of between 0 and 2 pi. So this particular answer has no solution. We don't even need to go to the second one, because if the first one's gone past 2 pi, the second one definitely will. So let me save this. And let's take a look at the next problem. So we got sine theta is equal to negative 1/2. Okay, so look at the instructions. Solve each equation, give a general formula for all the solutions. So let's go around a unit circle and look where it's equal to negative 1/2. Sine is our y part, so negative 1/2 be down third and fourth quadrant. Here's negative 1/2, 7 pi over 6. Negative 1/2. Here's 11 pi over 6. Of course, we know our next answer. We can take our first answer and add 2 pi, and that would give us 2 times 6 is 12 pi, 19 pi over 6. Our next one would be take our second answer and to add 2 pi. 2 times 6 is 12, so that's 12 pi plus 11 pi is 23 pi. Is that right? 2 times 6 is 12 and 23 pi. I guess it is. 12, 19, 12, 13, 23. Yeah, okay. Then next one would be our first. This is first angle, second angle. So if you're wondering like a pattern, this is your first, this is your second, this is your first plus 2 pi, this one's your second plus 2 pi. And then we'd have our first plus 3 pi. Well, that'd be 7 pi over 6 plus 2 pi. 2 times 6 is 12 plus 7 is 19. Over 6. And my numbers don't seem right here. Let's see. 2 pi, that's 12 pi over 6, 19 pi over 6. Oh, that's why they don't seem right. Should wake up before I create these videos, but I want to get an early start. That's not 3 pi, that should be 4 pi. Okay, that'll be better. Promise I'll wake up here. It's 4 pi. Okay, 4 times 6 is 24, plus 7 is 24, 31. 31 pi over 6. Let me double check the rest of these since I'm it's 11 pi over 6. And that's 12, 23. Okay. And then this one will be your second one plus 4 pi. So our second one is 11 pi over 6 plus 4 pi. 4 times 6 is 24, 34, 35 pi over 6. I was thinking in class that there's a different pattern here, but I guess not. Take a look at our from our first one to our first one plus 2 pi. And then from that one to the first plus 4 pi. 7 pi over 6 to 19 pi over 6. We added 12 pi over 6. And then we added 12 pi over 6 to get to this next one. Well, 12 pi over 6 is 2 pi. So this is like taking 7 pi over 6 and adding 2 pi over and over. Now I'll put an n here, and I'll say n is an integer. There's different ways of writing this. This is the form I like. Now our other one starts out as 11 pi over 6, and it goes to 23 pi over 6, and then goes to 35 pi over 6. Well, I'm adding 12 pi over 6 again, aren't I? So I'm adding 2 pi. So our second answer will be 11 pi over 6 plus 2 pi n. And n is an integer. And those will be your answers. Now sometimes you can see a pattern going from the first one to the second one to the third answer, the fourth answer, the fifth answer, the sixth answer. But if I go from 7 pi over 6 to 11, I'm adding 4. If I go from 11 pi over 6 to 19, I'm adding 8. And then I go from 19 pi over 6 to 23 pi over 6, I'm adding 4. 4 pi over 6. So that doesn't have a pattern. So that's why we have to take our first angle, add 2 pi over n, second angle, add 2 pi over n. Now some books will actually take this and merge it together with this, because you could take 2 pi over n plus times 6 plus 7 pi. But that's form, I'm going to leave them in. Yeah, let's look at our next problem. So we got tangent theta over 3 is equal to 1. And solve each equation, give a general formula for all the solutions. So we're not bound between 0 and 2 pi anymore. We're looking for infinite solutions. Okay. We got more than theta here. We got theta over 3. So after that little trick, we're going to look where tangent is equal to 1. And where tangent is equal to 1. And tangent is equal to 1. And tangent is equal to 1. That should be enough to see a pattern, I'd think. Okay. Well, tangent's y over x, and where it's equal to positive 1 at is where the x and y are the same, which is pi over 4. It's also down here, because these are both the same, so it's 5 pi over 4. Now, this next one here, this would be our first angle, which is pi over 4, and we can add 2 pi to it. And that's 2 times 4 is 8, plus 1 is 9, so we've got 9 pi over 4. This one would be our second answer, which is 5 pi over 4, plus 2 pi. 2 times 4 is 8, plus 5 is 13 pi over 4. Now, I don't think we'll need that fourth one, to be honest, but we'll have it just in case. Remember, we set theta over 3 equal to pi over 4 equal to 3 pi. It's 5 pi over 4, isn't it? Okay. And then equal to these. Okay, so theta over 3 is equal to pi over 4. Theta over 3 is equal to 5 pi over 4. Theta over 3 is equal to 9 pi over 4. Theta over 3 is equal to 13 pi over 4. Well, if I multiply both sides by 3, we're going to get theta is equal to 3 pi over 4. Here, if I multiply both sides by 3, I get 3 times 5 is 15 pi over 4. Here, if I multiply both sides by 3, I get 27 pi over 4. And here, if I multiply both sides by 3, we get, what, 39 pi over 4? Okay, let's look for a pattern. This one went from 3 pi over 4 to 15 pi over 4. We added 12 pi over 4. This one went from 15 pi over 4 to 27 pi over 4. We added 12 pi over 4. This one went from 27, and we added 12 pi over 4. Well, 12 divided by 4 is 3, so it appears like our pattern is we add 3 pi over and over. So we're going to take our first answer, which is 3 pi over 4, and we're going to add 3 pi over and over. And n is an integer. because if n is 1, then that's 3 pi. Here, going from this one to our third one, we'd add 6 pi, because this is 3 pi and this is 3 pi, so that'd be 6 pi. So if we put 2 in here, 2 times 3 pi gives us 6 pi. So those will be our answers. Let's take a look at this next one. We got cosine theta is equal to 0.27. Excuse me. Let me grab a drink here. Now this is saying use a calculator to solve this. Since it wants us to just use a calculator, I'm just going to go ahead and use the intersect method. You could take the inverse cosecant or inverse cosine of both sides and solve it in that manner, but why go to the bother if we're going to use a calculator anyway? So let's talk about the intersect method. Get everything on the left side. Excuse me. 0 on the right side. So for this particular problem here, we take the 0.27 to the left side. And we'd have cosine theta minus 0.27 equal to 0. Second step, put the left side on y1, 0 on y2. This process doesn't work unless you actually do that. Now what I'm talking about with y1 and y2, to go to our TA3, TA4 calculator. We're going to press our y equals, and on y1 we're going to put in our cosine theta minus 0.27. So I'll press clear to clear out whatever's there. I press cosine. I'll try it again. Press cosine, and theta, I'll just put x in for a variable. Doesn't matter what variable. Closing parentheses minus 0.27. And then I'll down arrow, and I already have 0 there, but if you didn't, you press clear and you put a 0 there. Now to begin with, to get our calculator set up for these particular problems, it says between 0 and 2 pi. So do a zoom and choose Z-trig, number 7. Now you do have to be in radians here, so if you don't see this picture, go to your mode and choose radians. Now, between 0 and 2 pi is the right-hand side here, from 0 to this. And our answers are where it crosses the x-axis. So let's talk about our next steps. We're going to do second trace. And then choose intersect. Let's see what I mean by choose intersect. So I come here, I do second trace. Now intersect is our fifth one. We can down arrow to it, highlight it, and press enter. Or you can just press the number that's in front of it. So if I press 5, then that'll do my down arrow and enter for me. Then we're going to enter on first curve. Let me go ahead and write this down. And then we'll also enter on second curve. Okay. So press enter on first curve. Press enter on second curve. Now, there's nothing special I'm doing there. I'm just pressing enter twice. If it won't let you go past one of those, won't let you go past first curve or second curve, it means you don't have 0 on Y2. So go back and do that. Now, what we're going to do now is use our arrow keys to move the cursor closer or close to your answer and press your enter. So over here, our cursor's right here at the origin. I'm going to press my right arrow key, moving it over closer to the answer I'm trying to find. Now remember, the answer is where it crosses the x-axis. So that's close enough. It doesn't have to be right on top of it, but it's just close to it. And then you press enter. It comes up and gives us the first answer. I can't hardly see that, but 2 decimal places, I think is what it said. 1.29, is that 297? So it'll be 1.3. Now we have a second answer over here. So what we have to do is we have to go through this process again. So I do secant, trace, choose my intersect, enter on first curve, enter on second curve, and I'll move my I'm going to do my right arrow key until I'm over closer to that answer. There we go. And then I'll press enter. And that gives us 4.985, so 4.99. And those will be our answers. And I might have room for this one. So let's just take a look at this one. This one's cosecant theta is equal to -3. And find the answer between 0 and 2 pi again. Well, remember, cosecant is 1 over sine. Equals -3. Now, our steps say to get everything on the left side 0 on the right side. So, I got 1 over sine, and I'll take -3 to the left side, so it becomes a +3, and then equals 0. So let's go input this now. So press my y equals, press clear, and I got 1 divided by sine x, closing parentheses, and then +3. Now we already have 0 on y2, so we don't need to put it there again, but if you don't, then make sure you have 0 on y2. Now let's do a second trace, choose intersect, number 5. Be patient. If you start pushing buttons before it comes back, it'll go to Never Never Land, and it'll be thinking forever. So wait till a little thinking process up here in the right-hand corner is done. Now, if it does go into Never Never Land and it sits there and there's 4 little dots going back and forth, press your on, and that'll set it back. Now our answer is where it crosses the x-axis, and we're looking from 0 to 2 pi, so we're only looking at the right side here. Now it says do enter on first curve, but notice it says y is equal to blank. If you try to press enter on it, it won't go anywhere. You have to press your right arrow key until you see a value in there, because at that first place our graph didn't exist. So now we can press enter on first curve, enter on second curve, and I want to move my cursor over closer to the answer I'm trying to find. And there we go. Then after I push enter, I see I got 3.48. Well, we have a second answer, so we have to do it again. So do second trace, choose intersect, enter on first curve, enter on second curve, and I'll move this over closer to this one. And then press enter, and we get 5.94. And those would be our answers. Let me save this page and we'll look at the next problem. This one we got 4 cosine squared theta minus 1 equal to 0. Now we looked at one like this earlier on, but now we're going to demonstrate these next few problems. The one technique you can use is to factor. So you see here we have, well, you may not see it, but we have two items, and it's something we can write as something squared minus something else squared. If I were to put a variable there instead of the trig function, like instead of cosine, let me put p in there. We got 4p squared minus 1 equal to 0. This is the difference of two squares. So we could rewrite this as 2p plus 1 times 2p minus 1. Like that. But we really don't have p there. We have cosine. So this would be 2 cosine theta plus 1 times 2 cosine theta minus 1. So we looked at this with the square root property, but here we're looking at it with factoring. So you can factor each one of these. Now from college algebra, you had the zero factor property. You get 0 one side, you factor the other side. Then you can set each one of these factors equal to 0. So set 2 cosine theta plus 1 equal to 0 and 2 cosine theta minus 1 equal to 0. And then these are now what are like the problems like we just looked at. So I want to solve for cosine. So here I'll take the 1 over the right side, becomes a negative 1. Divide both sides by 2 and we get negative 1/2. Here take negative 1 over, becomes a positive 1. And divide both sides by 2 and we get a positive 1/2. So let's go look on our unit circle where it's equal to either a negative 1/2 or a positive 1/2. Cosine is our x part. Here's a 1/2, pi over 3. Here's a negative 1/2, so 2 pi over 3. Come down to here, here's another negative 1/2, so 4 pi over 3. And here's a positive 1/2, so 5 pi over 3. So this is, instead of using a square root property, in some cases you can factor it, like we just did there. Let's take a look at another factoring one. So we got 2 sine squared theta minus 3 sine theta plus 1 is equal to 0. Now again, if having the trig part there is throwing you on the factoring anyway, then replace the trig part with a variable. Like put p there in for sine. So we got 2p squared minus 3p plus 1. And this would be the key number method of factoring. So this is 2p, p, 1, 1, minus, minus. So it factors that way. But we really didn't have p's there. We had sine. So this becomes 2 sine theta minus 1. And this is sine theta minus 1 equal to 0. Okay, zero factor property. You get 0 one side, you factor the other side, you set each factor equal to 0. So we'll set 2 sine theta minus 1 equal to 0. And sine theta minus 1 equal to 0. Solve this one for sine, so we'll take the negative 1 over, becomes a positive 1. Divide both sides by 2. And this one will take the negative 1 over, becomes a positive 1. Okay, so now we're going to go look where sine is equal to 1/2 or 1. Sine is our y part on a unit circle. Well, here's a y 1/2, so pi over 6. Here's a 1, so pi over 2. And over here, here's another 1/2 for our y, so 5 pi over 6. And those will be our three answers. Let's look at this one. got 2 minus 2 cosine squared theta plus sine theta equal to 1. Now, what makes these work out nice is if they're all have the same trig function. This, unfortunately, has a cosine squared and a sine. So one trick you have is try to rewrite them all so that they're the same trig function. Now recall, cosine squared theta plus sine squared theta is equal to 1. And we could, on this one, take sine squared to the right side. So we get cosine squared is equal to 1 minus sine squared. So what I could do over here is replace the cosine squared with 1 minus sine squared. So I got 2 minus 2 times 1 minus sine squared theta. And everything else carries down. Distributive property, negative 2 times 1 is negative 2. Negative 2 times negative sine squared is positive 2 sine squared. Yes. 2 minus 2 drops away. And then I got 2 sine squared plus sine. And I'll bring that 1 over the left side and becomes a negative 1. Now this is something we can factor. And again, if it throws you, put p's in over here. So 2p squared plus p minus 1. I modified this one from in class. It becomes a plus. This becomes a minus. In class, it came up with a no solution. Because it wouldn't factor, we used quadratic formula, and it still gave us answers that weren't valid. So I decided I only want one of those at the very end. So I modified some numbers, and this works out nice now. So this factors as 2 sine theta minus 1 and sine theta plus 1. We're just replacing the p's with sine theta. Okay, zero factor property. You got 0 on one side, you have factored the other side, so you set each factor equal to 0. And here we'll take the negative 1 over, it becomes a positive 1. Divide both sides by 2, we get 1/2. And here, take the 1 over, it becomes a negative 1. So if we look at where it's valid for 1/2, here's a 1/2, so pi over 6. The other one was 5 pi over 6. We've already looked those up. And negative 1, that's a new one. Here's negative 1, which is 3 pi over 2. Now, these would be our answers, but we would have to check it normally. You can use your trig identities to rewrite them in terms of other trig functions, but you want to make sure that the answers you come up with are valid for that trig function. But for sine and cosine, they're both valid in the same locations, so we're fine there. But normally you have to check your answers. I'm not sure if I got room here, so let me save this. We'll start a new page. Time for a little tablet to blow up, so there we go. So here we have cosine of negative theta plus sine theta is equal to 0. Okay. Now, whenever we have our negative angles in there, we can always use our even and odd properties to simplify it. And cosine's an even function, which means if you have a negative in there, you can just drop it. So this becomes cosine theta plus sine theta is equal to 0. Now we want to get these in the same trig function if we can. So I'm going to take one of those over to the right side. So I'll take the sine over, it becomes a negative sine. And we got the power principle, says you can raise both sides to a power. So let's square both sides. So if I square both sides, this. So we get cosine squared equals, and negative squared becomes positive, so this becomes sine squared. Well, doesn't matter which one you choose, but recall, we've already seen this, but let me write it down again. Cosine squared theta plus sine squared theta is equal to 1. So I could take the sine squared over to the right side, and we get cosine squared is equal to 1 minus sine squared. So we could replace the cosine squared here with 1 minus sine squared. So again, replacing that. Like that. Okay, so we want to get all the trig functions on one side. So I'll take this over here. And that gives us 1 equals sine squared theta plus sine squared theta, which gives us 2 sine squared theta. Divide both sides by 2, we get 1/2 is equal to sine squared. Now here we got something squared equal to the other side, so we can drop the squared and put a plus or minus square root around the other side. Well, we don't want a fraction inside of a square root, so we split it up, put a square root around top, square root around the bottom. And square root of 1 is 1, and that's square root of 2. Can't have a square root downstairs, so multiply top and bottom by the square root of 2. So that gives us square root of 2 over 2. Now if we look around our unit circle, where sine is equal to positive or negative square root of 2 over 2, that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Sine is our y. So square root of 2 over 2, negative square root of 2 over 2, negative square root of 2 over 2, and negative square root of 2 over 2. I should point toward the y's when I do that. We get these. You can use a power principle, but if you use a power principle, that plus we have two things here. We use a power principle plus we rewrote one of the trig functions. You have to check your answers. And if I put and I know that these first two are equivalent, so I'll plug it into here. If I put pi over 4 here, pi over 4 here, I'd get square root of 2 over 2 plus square root of 2 over 2, which doesn't equal to 0. So that one fails. If I put 3 pi over 4, cosine of 3 pi over 4, if I look at my unit circle, is negative square root of 2 over 2, and sine 3 pi over 4 is positive square root of 2 over 2. So this one checks. 5 pi over 4. If I put 5 pi over 4 in here, 5 pi over 4 in here, I'd get negative square root of 2 over 2 and negative square root of 2 over 2, which doesn't check. And 7 pi over 4 would check. So those are only the two answers. Now, a different way you could have done this problem is once you get down to this problem here, basically is asking when is cosine is equal to sine. And the signs are different since this is negative. Well, the only time the sine and cosine are equal to each other are at the pi over 4 marks. And here the signs are the same. Here the signs are different. So you could go directly to getting this instead of going through those steps. But I wanted to show that because that is one of your techniques. You can square both sides. Let's look at this next problem. Let me grab a drink first. This is another factoring one. Tangent squared theta minus square root of 3 tangent minus tangent plus square root of 3 equals 0. Now in factoring, if we had 4 more terms, we use factoring by grouping. We'll do the same thing here. We'll group these two together, and we'll group these two together. Well, these first two have a tangent in common, so I can factor out a tangent theta, and that gives us tangent theta minus square root of 3. Second group has nothing in common, but my first item is negative, so we'll factor out a negative 1. And that gives us tangent theta minus square root of 3. Factoring by grouping, we're trying to get these parentheses the same, and they are, so I can factor out a tangent theta minus square root of 3, and that leaves us tangent theta minus 1 equal to 0. Okay, zero factor property. You got 0 one side, you factor the other side, you set each factor equal to 0. So I'll set tangent theta minus square root of 3 equal to 0, and tangent theta minus 1 equal to 0. Well, here, take the negative square root of 3 to the right side, becomes a positive square root of 3. Take this over, it becomes a positive 1. Here we have pi over 6, and here we have pi over 3. This is square root of 3 over 2 and 1/2, and this is 1/2 and square root of 3 over 2. Now tangent is y over x. If I put y over x here, I'm going to get 1 over square root of 3 or square root of 3 over 3. If I put y over x here, I'm going to get, the 2's don't matter when you do that. So we've got square root of 3 over 1 or square root of 3. So tangent is equal to the square root of 3 at pi over 3. I forgot my theta there, but now also, if these were both negative, negative divided by negative is positive. So if I, by symmetry, here's pi over 3. If I go straight down here, this one is also 4 pi over 3. Now for these, tangent is equal to 1. Well, the only time you're going to get 1 when you got y over x is when y and x are the same, which is at pi over 4 and 5 pi over 4. Pi over 4, x and y are the same. 5 pi over 4, they're both the same. So those would be our 4 answers. Let's look at our next problem. Got sine theta minus square root of 3 cosine theta is equal to 2. Well, obviously I'm not going to be able to factor this at this point, so what I'm going to do is get one of the trig functions by itself. Doesn't matter which one you pick. I can't remember which one I did in class, but I guess I'll take this over to the right side. So we get sine theta is equal to 2 plus square root of 3 cosine. And we looked at the power principle earlier on where we could square both sides. So let's do that. So I've got sine theta squared is equal to 2 plus square root of 3 cosine theta squared. Well, that gives us sine squared there. And here I have to rewrite this as 2 plus square root of 3 cosine theta times 2 plus square root of 3 cosine theta. Well, 2 times 2 is 4. 2 times square root of 3 cosine theta is 2 square root of 3 cosine theta. Square root of 3 cosine theta times 2 is 2 square root of 3 cosine theta. Square root of 3 times square root of 3 is 3, and cosine times cosine is cosine squared. Okay, so you look at that, it's like, well, it doesn't appear to be closer. Actually, let me combine these together. 2 square root of 3 cosine theta, 2 square root of 3 cosine theta becomes 4 square root of 3 cosine theta. And you look at that, so it's even more of a mess now. But we can now switch the sine squared over to cosine. So recall cosine squared plus sine squared is equal to 1. So I can take the cosine squared to the right side, and we get sine squared is equal to 1 minus cosine squared. So this I'll rewrite as 1 minus cosine squared. Now I want to take these over to the right side. So we get, and I'll rearrange them. So I'll put 3 cosine squared first. Sort of got kind of sloppy dropping my variable there, but that should be theta. There we go. This is theta here too. Okay, and then the negative cosine squared I'm bringing to the right side becomes a positive cosine squared. Then I have 4 square root of 3 cosine theta plus 4, and then the 1 I brought over becomes a negative 1. So 3 cosine squared plus 1 cosine squared is 4 cosine squared plus 4 square root of 3 cosine, and 4 minus 1 gives us 3. Not quite sure how to tell people how to factor this. So let me go ahead and just factor it. This doesn't fit your normal factoring because we never had square roots in college algebra. But basically, if you have something like this and you have a square root in here, then pretty well, I shouldn't say 100% of the time, but maybe 95% of the time, what you're going to find is that if you take the, you ask yourself on each piece here, what times itself gives you the 4? That's 2. What times itself gives you cosine squared? And that's cosine. Then if you look at this last one, what times itself gives you 3? And that would be square root of 3. Square root of 3 times square root of 3 gives you 3. And then if everything's positive, these are both positive and they're the same. So that'll happen whenever you see the square root in there. Pretty well, that's probably what's going to happen factoring-wise. So now, if I set each one of those equal to 0, they're both the same. So I only need to set one of them equal to 0. Then I want to solve for cosine. So I take the square root of 3 to the right side, becomes a negative square root of 3. Divide both sides by 2. And we get that. Okay, now let's go look on our unit circle, where cosine is equal to negative square root of 3 over 2. Cosine is our x part, 5 pi over 6. And down here, 7 pi over 6. Well, we squared both sides, which means we have to check our answer. 5 pi over 6. If I put that up in here, here's 5 pi over 6. Sine would be 1/2 minus square root of 3 times, and x is our negative square root of 3 over 2. Negative times negative is positive. Square root of 3 times square root of 3 is 3, so that's 3/2. 1/2 plus 3/2 gives us 4/2, which is 2. So that checks. If I check the other one, the 7 pi over 6. Actually, let me write those steps down, so I think I have room here. Check. What we do is we plug that into our original equation. So we got sine 5 pi over 6 minus square root of 3 cosine of 5 pi over 6. And this is a question mark if that's equal to 2. Well, sine 5 pi over 6 we said was 1/2 minus square root of 3, and cosine 5 pi over 6 is square root of 3 over 2, negative square root of 3 over 2. And that gives us 1/2 plus 3/2, which does equal to 2. Now if I plug in 7 pi over 6, we've got sine 7 pi over 6 minus square root of 3 cosine 7 pi over 6. And this is a question mark if that's equal to 2. Well, sine 7 pi over 6 is negative 1/2. Cosine of 7 pi over 6 is negative square root of 3 over 2. So that'd give us negative 1/2 plus 3/2. And that does not equal to 2. That equals to 2 over 2 or 1. So that one fails. So our only answer is 5 pi over 6. Remember, if you square both sides, use the power principle, you have to check your answers. So let me save that. And let's take a look at the next problem. Cosecant theta equals tangent theta plus cotangent theta. I don't think squaring both sides would help us on this one, but recall cosecant theta is equal to 1 over sine theta. Tangent theta is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta. So we can try to put everything in terms of sines and cosines and see where that goes. So cosecant is 1 over sine. Tangent is sine over cosine. And cotangent is cosine over sine. Now, instead of having 3 trig functions, we only have 2, so we're a step closer. Well, we can get rid of the fractions by multiplying everything by the LCM of all our denominators, which would be sine, cosine. So multiply it times 1 over sine. I'll multiply that times sine over cosine. And I'll multiply that times cosine over sine. Here the sines cancel, here the cosines cancel, and here the sines cancel. So we're left with cosine theta equals sine times sine is sine squared, and cosine times cosine is cosine squared. Now this one even works out even nicer because recall sine squared theta plus cosine squared theta is equal to 1. So this right hand side just becomes 1. And the only place where cosine is equal to 1 is at 0. So that'd be your answer. Maybe. I shouldn't have circled that yet. Remember, we have to check our answers. If I put, if I look at my unit circle, it's easy way to see it. So it's 0. Okay, cosecant is 1 over y. Well, y is 0 here, so we'd have 1 over 0, so that's undefined. So that's a no solution. Now remember, if you can use the identities to rewrite them into other trig functions. But if you do that, you have to check your answers, make sure it doesn't cause something to be undefined in your original problem. I almost missed that one this morning. Now I have no excuse because I'm kind of woke up now. I still halfway asleep when I started this. Okay, so x squared. Math not only heals, it wakes you up too. Now here's another calculator one. So let's go ahead and do this. Now remember our steps. Get everything on left side, 0 on right, and then we're going to input in our calculator. So press y equals, press clear, and we've got x squared. So x squared minus 4 cosine. So 4 cosine x. Put a closing parenthesis if you want. Have to have 0 on y2, otherwise this process doesn't work. You have to be in radians too. Now, if you've changed your calculator, again you have to do zoom z trig to put it in the right form, because we're wanting it between 0 and 2 pi, I believe. Must not matter on this one. Okay, so it didn't say. So let's do a second trace. Choose intersect. kind of like a parabola type thing. So we'll find these two answers. So push enter on first curve, enter on second curve. I'll use my arrow keys and move over close to the one I want to find. That one right there. And I'll press enter. And that gives us negative 1.2. Now let's do the other one. So I'll do second trace and choose intersect. Enter on first curve, enter on second curve, and I'll use my arrow keys and move over close to the one I'm trying to find. And press enter. And we get a positive 1.2. The question is, does it come back down? So let's just do a zoom just for fun. And I'll see, zoom out. Number 3. And then I'll press enter one time. Press enter one more time. You want to make sure it comes back before you keep pressing enter. It doesn't look like it's coming back down. So I'm going to do my zoom and set it back to Z standard, number 6. So these would be our two answers. How can we verify that it never comes back down? Well, that's calculus. That's not trig. So don't worry about that part. Let's take a look at this one. This one's a really nice one. We got tangent squared minus 8 tangent plus 1 equals 0. Now this doesn't factor. So what we're going to do is we're going to use a quadratic formula. Now your A will be whatever's before your trig function squared, which is 1. Your B is going to be whatever's before your trig function, which is negative 8. And your C is a number at the end, which is 1. Now instead of this being x equals, it's going to be tangent x equals. And let me write this down. Negative b plus or minus square root of b squared minus 4ac all over 2a. So we got negative 8 plus or minus negative 8 squared minus 4 times a times c all over 2a. Negative negative becomes positive, so we got positive 8 plus or minus negative 8 squared is 64 minus 4 times 1 is 4 over 2, which gives us 8 plus or minus square root of 60 over 2. Which gives us 8 plus or minus 60 is 2 times 15. Bring out a 2, because remember square root, we're looking for a pair of somethings. And remember, if you can divide this number, and this number by the same number, do so. And they're all divisible by 2. So we got tangent x is equal to 4 plus or minus 1 square root of 15 over 1. Or tangent x is equal to 4 plus or minus square root of 15. Now we're solving for x, so we'll go ahead and take inverse tangent on both sides. And these are going to cancel each other out and give us x. So x is equal to inverse tangent of 4 plus or minus square root of 15. Now I changed these instructions to be specifically between 0 and pi over 2. Because both of these, I believe, come between are in that value if you were to plug them in. I wanted to come up with something where you didn't have to do any kind of checking. You could come up with this, and that would be your answer. Now, I don't think in this particular textbook that there's any trig equations where you have to use quadratic formula, but if there was, this is how you do it. So, and that's an exact answer. That's not an approximation, which is what the intersect method gives us. So let me save that. And then we'll be done. So stop my recorders. tablet blows up.